So a lot of this ties into work that I was working on previously, and like theories of something that could work but haven't really put into production. Another theory I did, I put that into something personal of mine. But there was another very outstanding theory, which was essentially taking that technology and making it into like an execution layer, but like an execution layer on steroids. So essentially, uh, for developers, they want to basically write exactly how they write any other program. They don't want to, uh, learn like really complicated SDKs. And there is a way to actually break down a typical program into its components and use it within this system. So the system is, what if we could have a world where you have one program and it has a bunch of functions, has a bunch of methods in it, it's got API endpoints, and everything inside is kind of a black box. But instead, what if you can make it very modularized? So you're able to essentially take pieces of that program and reassemble them to create new programs, right? So you're going from creation, building something that is relevant to you, to someone going, there's 10 projects that are doing kind of what I want. Now, what if there's a way that I can just write in plain English exactly what I want, and an AI system is actually able to self-assemble this agent from these components of other agents? Now, that is possible. And the research behind it spans about 60 years, from the 1960s all the way till modern day, but primarily around the 1980s. And this is the idea of neuro-symbolic AI, which is different from generative AI. Key advantage to it is essentially that it's fully explainable. You know exactly how something is going to execute. It can explain it exactly. You can see your processes as it executes, and we can go into a world where essentially that instead of having just like agents that this guy built and that guy built and that guy built and that guy built, instead we can have these broken down into components, and someone can describe what they want, and it will use what's out there. Now, in the cryptocurrency world, that is fantastic. If you have fully vetted code, like let's say someone got an auditing company to audit their project end to end, and their code is vetted in that way. Well, we can attach something really important in these systems, which is a well-described component of this system, which is provenance. We got proof from somewhere that this is safe. So what's wild with that is that you're essentially able to follow pathways from your intent to going down to where that first part of that component is, and it will follow paths through a graph to be able to assemble this one agent. But not only that, it's bumping up the salience. So over time, the more you use it, it'll start to learn what agents you like, what pathways you do. And there would be less hand holding with it the more you interact with it. So it'll actually be able to understand your preferences as you do things. So for example, let's say there's an agent that some company made that is a DEX, right? In the beginning, it's going to ask you, do you want to use this DEX? Do you want to use this DEX? But then over time, it'll go, okay, actually, this guy obviously wants this DEX, and it'll start using that DEX. But let's say that you want to do something quite complicated, like and something that a lot of people think is not possible in a typical cryptocurrency world. I want to trade 10,000 USDT to a Bitcoin, and then I want to send a message to this group on Telegram saying that I traded this currency. Now, there's a few bridges there, right? Like, what if he said, I want to trade 10,000 USDT to Bitcoin on Ethereum, and then message someone on X that I did that trade, right? Now, what's cool about that, you can start having these agents. One is for X, and that can live locally on your system, which you plug into your thing. It's still part of the greater system. So there's two systems. There's one local, one global. Your local one works seamlessly with the global one. So you're able to actually attach what is actually connected to you through the entire pipeline, which opens up a bunch of exciting opportunities. So I got a demo just to demonstrate kind of what I mean. Now I could throw on a bunch more agents, but I ran out of time, but that's okay. I think it should be able to demonstrate exactly what I'm trying to explain. All right, can you guys see this?
Yep.
Okay, so this is a simulated environment. We have 100,000 USDT, a swap agent, which is, it has its own methods, it has its own logic, that's all internal. It has, it's basically a self-contained agent, and we have a ping agent. So what's cool is that I can say, I want to swap 10,000 USDT to Bitcoin, right? So now we can see that we have now 90,000 USDT, and we got Bitcoin. Now, for most intent-based systems that people are aware of in Near, that's basically all they do. They don't do much more than that. But there's something peculiar about the execution step. We got step one, and we swap USDT to BTC. Okay, cool. Well, let's do this. I want to swap 10,000 USDT to Alpha, 5,000 USDT to Ethereum, and then $500 to Near. So what this was doing is that this doesn't need to be a big model. This can be a really tiny model. It can be a model that can fit on your phone, because the system actually isn't the LLM. It's what the LLM is working with, which is another AI system. In fact, it's a precursor to generative AI. And excuse the formatting, but you can see here we swapped 10,000 USDT to Alpha, 5,000 to Ethereum, 500 USDT to Near, and all three swaps executed without any errors. Your transaction involved converting 15,000 into 3 separate currencies, and here's the steps. Okay, that's kind of impressive. Now, let's try this. I want to swap 10,000 USDT to Alpha, then to Bitcoin, then to Ethereum, then back to Alpha, then to Bitcoin, and then back to USDT, and then back to Bitcoin. Because intents that you see in cryptocurrency can't do this.
Does it assume that those coins are all breached to Unicity, or it kind of works
They
on
could be. Yeah, no, they could be. All right. So we started with my 10,000 USDT. Well, then we swapped that to Alpha. Then we took the Alpha and turned that to Bitcoin. Then we took the Bitcoin and exchanged it for Ethereum. Then we took the Ethereum and swapped it back to Alpha. And then we took the Alpha, swapped it again for Bitcoin, Bitcoin to USDT, and finally, as requested, this USDT, you now hold this much Bitcoin. And you can see how this interflowed with each other. And it actually took the output from this and routed it to here. Took the output of this, routed it to there. Took the output of this, routed it to there. It made a whole pipeline, a step-by-step pipeline. There's a whole pipeline that is being assembled from the moment that something comes in. So let's take this one, for example. There's an intent that was created out of what I said. User wants to perform 3 separate swap operations: convert 10,000 USDT to Alpha, convert the 5,000 USDT to Ethereum, and convert 500 USDT to Near tokens. That's all the LLM writes. Then the other AI takes this intent and proposes a flow. So it'll start to make a flow, and it will send it back to the LLM for approval. I just added a bit of like hand holding for it for now, but in a real system, it shouldn't need to ask the LLM, is this correct? So it's composing the flow from transaction pipeline. It found that there was a ambiguous method match, so it wasn't sure to use this or this. So it's going to request the LLM for approval. LLM looks at it and it goes swap USDT to Alpha. Its confidence is nearly 100%. And the LLM responds in plain English back to this other system. So the user wants to convert 10,000 USDT to Alpha cryptocurrency tokens. This is a direct swap from USDT to Alpha. This LLM is not writing in programs or anything else like that. It is communicating in pure English to the system. But what this is another neural network, which is called a symbolic AI. And it essentially was created, or it was explored up until around the 80s. And then generative AI took over. And this form of AI kind of got forgotten. Now, what me and a few others have realized was that if you combine both of them, absolute pure magic happens. In case of this demonstration, for example. So, and the other cool thing about this system, this is what runs Google. This is how you write a query and you get results. It's very similar to that. And as we can tell, like, how scalable is Google, right? Can you imagine running programs at the scale of Google, which not just humans can program in plain English, but also other AIs? So it's proven technology. It's not saying, oh, maybe it will scale. Like, this is known to scale.